Hello guys, so in today's tutorial we'll be start dealing with TensorFlow, and from next videos onward we'll be dealing with tutorials related to TensorFlow, and you will have a complete course and guidelines how to build machine learning and deep learning expertise or projects using TensorFlow, step-by-step explanation and codes. Okay, so without any intervention or wasting of your time, let's start. So first thing, in today's video we'll be deal about the hello world of basically deep learning or TensorFlow and the neural network basics. So it's better to start any machine learning or deep learning projects with numbers, because internally any machine learning model will understand and appreciate numbers, right? So as we'll be going through this whole notebook, it won't be a much long tutorial. Okay, so let's start with something simple, right, for this neural network code basically. So what we are trying to do here, that we are having one function. That function is basically a response and independent variable. So here x is the independent variable and y is the response of x, and we're creating one function or equation that is y is basically twice of x plus 3. Okay, so a pretty straightforward straight line, right? Y equals to mx plus c, as you can see. And we will see how our machine learning model, or basically this neural network, right, is helping, this neural network, with help of the data that will be feeding or providing, predicts the value of y, or learns the value of y by providing the value of x. So this is the rule, and we are going to omit or delete the rule by using machine learning frameworks, and we are going to build the expertise to be a TensorFlow developer step by step, right? So the first thing first, we have to import TensorFlow. So here you can see we're importing TensorFlow and aliasing as TF. Then we are importing NumPy. Then we are importing Keras from TensorFlow. So in backend of TensorFlow, we are going to use this Keras, which has inbuilt APIs for building machine learning, basically neural networks, and dealing all kind of neural network parameters and all, right? So from scratch we don't have to write anything for building the neural networks. It's already implemented in Keras, and via TensorFlow we are going to use that, right? So these are the three things we are going to do, and we are going to just print the version here. As you can see, if we write it down, so we have 2.15 version of TensorFlow currently. Now the next task for any machine learning model or your TensorFlow, any neural network, is you have to define the network. So your network is nothing but sort of neurons connected and dependent using some nonlinear net activations and all. So that with things will deal step by step. First thing, as you can see, let's start from the very inner basics, right? So this dense is nothing but your dense layer. So three things, let's write it down, right? First, what we are going to occur. So with time we'll get to know with this course. So dense, first thing that we are getting here, so it is nothing but your layer that is required for building your neural network, right? Now the second thing that we are going to see here is sequential. So just making it as seq. So as you can see, after dense, which we are fetching from Keras, we are seeing that is sequential model, right? So what this sequential is nothing but dense layer feeding one after another, right? So if you see, you have dense layer, right? 1 2 3 4 dense layer, like straightforward things. So your dense layer will be like, let's say we have one dense layer, then again there is another sequence, then again we have dense layer, then another sequence again. So like this, right? So like this we'll be having, so on. So this how the neural network will form, and sequential will help build the structure. Okay, now we are again importing it from Keras. So without further, just run this, and as you can see, the model is getting imported. Now as we have mentioned, right, so we'll be dealing with this y equals to 2x plus 3, this simple example. So for that, Once the model is built, we need to compile the neural network. To do this, we require two functions. So as neural networks and machine learning or deep learning is mostly dealing with probability, statistics and all, so it is better to start understanding those one by one and get a deep and develop a what habit or attitude towards learning them if you want to become a good machine learning or data science engineer in this field in future. So two functions, one is loss function, we'll just go to the links, and one is optimizer that will be uh, dealing, right? So the first one, as we're using this Keras API, right? So losses. So the purpose of loss function is to compute the quantity that a model should seek to minimize during training, right? So what is the loss function? Is basically, let's say you have a target, right? Let's say you are predicting something and your input value 2x plus 3, right? This is the rule that we want to predict from x and y. So let's say we are passing 1 as x, right? So our target output should be 5. So in y we should be expecting 5, right? So if let's say we are getting 6, then your loss will become based, let's say, any function. So we are defining, let's say 6 minus 5 as a loss function. So our loss is 1, and the target of the loss function is to minimize this. So it should be 0 ideally, right? For any minimization thing, right? So that is the function of this loss function. It tries to minimize the error, basically whatever error we can see, and these are all type of losses that you can see. These are losses for your probabilistic model, these are the losses for your regression model, then you have hinge losses for maximum margin classification and all, right? So we'll be going all of these details later in later courses, right? And the next one is again optimizers. So what is the job of optimizer? Basically, how I would like to reimagine this is we are passing the data to loss function, and the loss function is making some guesses, right? Let's say in the first run of 2x plus 3 with x equals to 1, it is making a guess of 7. Then it gives a loss of 2, right? Then again it passes the data to the optimizer again tries to optimize the value of x further, basically, or whatever function it is trying to predict, right? That function, and the target of the next approach or next iteration or next learning section will be I have to give a loss function that will be lesser than 2, right? That will be seen in the next section. Okay, so these two functions, first we have to understand, one is optimizer and one is loss function, right? So as I mentioned, loss function's task is to minimize the losses that occurs during training, and the function of optimizer is to optimize the function so that you can have lesser or you can have lesser of loss, right? Now again, what we are trying to achieve here, we are doing compilation. So this compilation phase will take on these two basic minimum parameters for your TensorFlow model or whatever your deep learning models, and in backend it will call the Keras optimizer and Keras loss parameter with this compile method, right? So we are doing calling the compile method for compiling and making this model complete model, and we are passing SGD as optimizer and MSE as loss for now. So don't worry about all of this, whatever written here, right? We'll go deeper in our next tutorials and we'll be having better understanding step by step, right? So once this model is compiled, right, we can then print out the model. So let's model.summary, it uses to print out the model. So if you print this model, you can see there is only one layer, right? So how can you define this one layer, right? So you can see this input shape and unit, right? So this unit is the node of the uh, neural network. So currently we have set it as 1, right? So and that's why you can see there is only one dense layer with input shape. It is provided as 1, so it's only a single vector like we are currently providing. So the shape is nothing but basically it's a scalar that we are passing, that's why it's only 1, right? And in output also, as we are passing a what single value or scalar kind of a vector. So scalar is nothing but your zero vector, right? Zero vector or zero tensor, the way people like to imagine. And the output will also be one value because a regression problem and all, right? And we are passing we are trying to teach two parameters here, right? So how many parameters will learn basically in this course of training? It's only two. So this is the whole model's summary, and the model name is sequential one here. So you can see all the trainable and non-trainable parameters. So it is 2 and 0 currently here, but for normally neural networks it is going to be huge in billions or millions at least, right? So we'll be dig deeper later about all the different type of loss function and optimization. So for currently you need to learn what first thing you need one model. You're right. Then you require this compile method for compilation or make the model a complete model, and then you can print the summary. These three lines right now we have learned, and now the next one is defining the data, right? So for defining of the data, for dealing with any kind of numerical values, basically in Python we have a very strong library called numpy. So if you see this numpy, we are dealing we have already loaded the numpy as np, right? So np is the alias name for loading numpy. Now if we call np.array, let's say we have already loaded, right, np, and if we do a tab or shift tab, right, I forgot, and you can see, right, so you can see all the options coming here. So np.array, what will create, it will create a array structure. Okay, so let me just quickly go through over. So it will quickly create one array structure. Let's say right now we are passing a list, right? In Python this data structure is nothing but a list. So we are passing a list, a list which is Python data structure, and it is right now being converted to numpy array. Okay, so this is the first thing we are doing, and we are doing it for both x and y's. So for x we are passing this sample of data, 6 data points, and for y's we are also passing 6 data points. And you remember our y, we have defined a rule, right? Y equals to 2x plus 3, right? That is the rule. Yeah, that is the rule that we have defined. So you can cross verify here, right? So we have -1. If you put -1 here, you will get 1, and so forth. And so we will be feeding this data to our this neural network that we have just built, and we'll be expecting the neural network to learn and give us output. And in that way we can eliminate this rule, and we can only feed data to get output. And that is the very basic of, you can just say hello world of TensorFlow, right? So the page is open. Yeah, so you can read more about this numpy array, what array does, and it's pretty much simple. It's nothing, it's similar to list but has more capabilities in terms of memory optimization, working with big data and all, right? Okay, you can go through it. Will be linked down these pages, right, in this tutorial anyways. Now training the network. To train the neural network that we have just created using the help of TensorFlow and Keras, we have to call this fit method. So we have created this model, right? So model.fit will give you the training of this neural network, and we are passing the x and y, that means the dependent and non-dependent variable. So your dependent variable is y and your non-dependent variable is x that we are passing, and you are also passing the epoch. Epoch is nothing but the number of time it will iterate or train, right? So currently it is kept as 1000, and you can see that with increasing number of epochs, by keeping your data pretty much same, you can learn a lot. I mean, your model can learn a lot, right? So that things will be exploring later. So right now your x and y's, let's load those and then learn this model dot fit, and you can see it starts training, and you can see in every step, right, if you don't use the special parameters, right, it will print all the steps and the loss functions by default, right? As you can see, the more it is the epoch value is getting higher, right, or incrementing, the loss function is decreasing, right? So that is the idea we have already mentioned in this optimizer and loss functions time, right? So that idea is to iterate and go from loss to optimizer to again loss to optimizer in the similar loop, and the target is to reduce this loss function, right, so that it can achieve a minimum value. So as you can see, after 1000 steps, the loss is pretty much very less in 10 to the power minus format. So if I go quickly jump over to the last, So 10 to the power minus 8 or 9 it is going, that means very minimal loss, right? So for better visibility, let's just hide this output. And once we have already fitted the model, that means our model is ready, it has learned whatever it needs to learn between the relationship between x and y. Then for prediction, to test or inference, that we called in statistics, we have to call this predict method, right? So this model dot predict, what it will do with the newer values coming from the data from user or whatever app or use case you are building on, so it will then show, okay, whether it has learned anything or not, right? So remember, for y we are getting this is the actual rule based on which we have built this data, is 2x plus 3. So once you run and pass the value of 8, you should be expecting around 19, because 2 times 8 is 16 plus 3 is 19, but you should not get exactly 19, and that's why machine learning, right, it should have some kind of some minimal amount of error that is already included there, right, in terms of bias and all. So you can see it has learned very much well with 1000 epoch, and you can see the value is 19.000118, so which is not exactly 19, but kind of very much close to it. So that's it for this video. We'll be seeing in the next